This page of problems is a rather essential page of problems, so I want you to pay very close attention as we look at it. F of -4, that says find the y value when -4 is plugged into function f. Notice that function f is the blue graph that I have here. So I'm going to go to x equals -4, down to the blue graph, and notice that it's at a height of -2, and that becomes the value of that function. F of 1, go to the x value of 1, which is the input, and go up to function 1, which is at a height of 2, and so f of 1 is equal to 2. G of -2. -2 is here to the left. G is the red graph, so up to the red graph, which is at a y value of 2. G of 3, here's the 3. G is the red graph, so we go down to -3 as an output. And f plus g of 2. Okay, now I need f of 2, which is at a height of 2, g of 2, which is at a height of -2. So I have 2 plus -2, which gives us a value of 0 for that sum. G minus f of 3. Well, at 3, g is -3, minus f, which is at a height of +3, and so we get -6 for that part. F times g of -1. At -1, both functions have a value of +1, so we really have 1 times 1 here, which is equal to 1. G times f of -4. At -4, g is at a height of 2, f is a height of -2. So this will be 2 times -2, giving us -4. Now let's look at some quotients. G divided by f of 0. Here we go to 0 as the input. G of 0 is 0. F is at a height of 2. So we have 0 divided by 2, which is 0. F divided by g of -2. At -2, f is at a height of 0 and g is at a height of 2. So we have again 0 over 2, which is equal to 0. Now f divided by g of 0. At 0, f is at 2 divided by 0, and whenever we divide by 0, we get undefined. G divided by f of -2. This is going to be 2 divided by 0, the reciprocal of what we basically did back in problem 10, and this will be undefined also. So notice how we're being very careful as we read through these parts. Now we have composite functions. This is where we're going to begin by finding f of -1. Now f of -1, that says take -1, go up to function f, which is a height of 1. So that says take that 1 and then substitute it into g. G of 1 is now down at a height of -1. Next problem, g of 0, let's find that first. G of 0, well, at the red graph is at a height of 0, so that is 0. That gets substituted into f, so we have f of 0. We go back to our graph. 0, f graph is at a height of 2, so the value of the function there is 2. G composite -4, g of -4. Go to -4, up to graph g, that's at a height of 2. And so we have f of 2 now. Take 2, go into function f, that's at a height of 2. G composite f of -4. First find f of -4. Here's -4. Function f is down here at a height of -2. So g of -2. Go to -2, up to graph g, which is the red one, which is at a height of 2, and the answer there is 2. G composite g of 2. Go to 2, down to the graph g, which is at a height of -2. Now we've got g of that -2. Go to graph -2, up to the height of the graph, the red graph, which gives us a final answer here of +2. And finally, f composite f of -2. Find f of -2. Negative 2 is right here. The height of the blue graph is 0. So we now have the outside f evaluated at 0. We go to 0 for x up to a height of 2 on the blue graph, and so this is going to equal 2. Okay, now that I've done this one for you, I highly suggest you stop this and do the next problem on your own, and then start this back up again. Here we go. A is the blue graph, B is the red graph, A of negative 3. We go to negative 3, A is the blue graph down here at negative 1, so that value is negative 1. A of 1, go over to 1 up to the graph, which would be at a height of 3. B of negative 1, that says go down to the red graph, the output there is negative 2. B of 3, here's x equals 3, the red graph is at a height of 0, so that is our value there. A minus B of negative 1, at negative 1, A is at a height of 1, B is at a height of negative 2, so minus a negative 2 there, which really gives us 3 as an output, so you've got to be careful. A plus B of 0. At x equals 0, A is at positive 2, B is at negative 2. So 2 plus negative 2, that gives us 0. B times A of 1. At 1, B is down at negative 2, A is up at 3. So we have negative 2 times 3, which is negative 6. A times B of 2, here's our 2. A is up at a height of 4, B is at a height of negative 1. So 4 times negative 1 is negative 4. Now we move into the composite functions. A of 0. At 0, A is at a height of 2. So we have 2 now getting substituted into B. So B of 2, that says go to 2, down to the B graph, which is the red graph, and we have negative 1. B of negative 2, go over to negative 2. The height of both graphs is 0, so B of negative 2 is 0. So 0 gets substituted into A. A of 0 is up to a height of 2. A composite B of negative 4. Let's find that B of negative 4 first. Here's our negative 4. Graph B is up here at a height of 4, which then gets substituted into A. A of 4, here's my 4 up to graph A, final output, height of 4. A of negative 3, let's go to negative 3, graph A is down here at negative 1, so B of negative 1, go to negative 1 as the input, down to graph B, which is at a height of negative 2, and that will be the answer to that composite function. Then we have a quotient, so we need to find B of 3 divided by A of 3. At 3, B is at a height of 0 and A is at a height of 5, so 0 divided by 5 is 0. A divided by B of 4, at 4, A is at a height of 4 and B is at a height of 1, so 4 over 1 is 4. And then another composite function, negative 2 going into A. Negative 2 goes into A, the blue graph is at a height of 0, which is now the input into the other A. A of 0 here, go to a height of 2, and so final answer there is 2. Okay, so if you can do these, you really know what's going on. Let's move down here to the final problem in this section. We've got a cost of producing X toy cars is given by this cost function. Notice we have cost as a function of X, and we have a revenue function also in terms of X. So to calculate the profit, we want to subtract one from the other. So I'm going to say P of X, the profit, is going to be the revenue, the amount of money you take in, minus the cost. So the profit is going to be 5.98x minus this 2.2x plus 1. And we can write this now as the profit will be, when we subtract, we're going to have 3.78x minus 1. Be careful to distribute the negative. Then it's asking us to find the profit when you have 50 cars. So part B, P of 50 will equal 50 substituted into this function, so 3.78 times 50 minus 1, which I've already done on a calculator, which comes out to be 188, and this problem is in dollars, and so that becomes the answer to this problem.